All right, section 6-2, properties of parallelograms. So today we're going to prove and apply properties of parallelograms and also use those properties to solve problems. So first of all, what is a parallelogram? Well, a parallelogram is a quadrilateral with two pairs of parallel sides. So here's an example of a parallelogram right here. This is parallelogram ABCD. You'll notice that there's a shorthand way of writing parallelogram, just like there's a shorthand way of writing triangle, and it looks just like a little tiny parallelogram. So you can use that instead of writing the word parallelogram, you can use that symbol instead. So first of all, there's some things you need to know about parallelograms. One is that the opposite sides are congruent. So if this is a parallelogram, then I know that AB is congruent to CD, and I also know that AD is congruent to BC. Okay, opposite sides are congruent. Also, you will know that opposite angles are congruent. We're just going to use the same picture that we had above and not redraw it. So opposite angles are congruent. So angle A is congruent to angle C, and also angle B is congruent to angle D. These are opposite angles here and opposite angles here. Okay? Also, consecutive angles are supplementary. So consecutive means next to each other. So that means that A and B, so the measure of angle A plus the measure of angle B equals 180. It also means that B and C add to 180. So the measure of angle B plus the measure of angle C equals 180. It also means that C and D add to 180. The measure of angle C plus the measure of angle D equals 180. And lastly, of course, A and D also add to 180, so the measure of angle A plus the measure of angle D equals 180 degrees. And then the last thing to learn about parallelograms is that their diagonals bisect each other. So that means that AX is congruent to XC, and it also means that BX is congruent to XD, okay, because the diagonals bisect each other. All right, let's take a look at the next page here. So on the next page, let's draw these 5 different things about parallelograms that we learned. Opposite sides are parallel, so that looks like this, with the little arrows meaning parallel. Opposite sides are congruent, so that looks like this. Opposite angles are congruent, so that looks like this. Consecutive angles are supplementary, so if this is X, this will be 180 minus X. And this is going to be X, so this is 180 minus X. And lastly, that the diagonals bisect each other. So this is congruent to this, and this side is congruent to that side. Okay? So let's have 2 examples down here to do with you. First of all, we want to find out what AD is. AD equals what? So that's our goal. And secondly, we're going to find out what the measure of angle B is. Okay, so how do we find out what AD is? Well, AD is opposite of BC. Oh, I forgot to tell you that I'm given that this is ABCD is a parallelogram. Okay? So if this is a parallelogram, that means that AD has to be equal to BC because opposite sides are equal. We learned that here. Okay, so that means we can just plug in what we know. So AD is 7x, BC is 5x plus 19. Okay, and we find out that x is 9.5. Now we're going to plug it back in. So AD is 7 times 9.5, which gives us 66.5. So 66.5 is the length of AD. Okay, now let's find out how to find measure of angle B. Well, measure of angle B, and I know measure of angle A, those are consecutive angles, which means here they are supplementary. So the measure of angle A plus the measure of angle B equals 180 degrees. And we know that because consecutive angles are supplementary. So now let's plug in what we know. Angle A is 10y minus 1, and angle B is 6y plus 5 equals 180. And after you solve for y, you're going to find out that y equals 11. Then you need to plug it back in. So measure of angle B equals 6 times 11 plus 5. So that equals 71 degrees. Okay? So that's how we use those. Now let's do this one here. These are diagonals, and we want to find out what GJ is, and I forgot to give these names here. So this is J, this is G, E, H, and F. Okay, and we're also going to find out what FH is. Okay, so that's our goal. I didn't mean to put a segment symbol above this one. Okay, there we go. All right, so now GJ is congruent to JE. So JG is equal to EJ because diagonals bisect. And so GJ is W plus 8, EJ is 3W, so that's W equals 4. So now plug it in and we get 12. Okay, because 4 plus 8, so JG equals 4 plus 8, which is 12. Okay, for FH, FH is this whole entire thing. Well, I know that FJ is equal to JH, also because diagonals bisect. So FJ is 4x minus 9, JH is 2x, and so we get 2x equals 9, so x equals 4.5. So this side here is 4.5 times 2, which is 9. And so this is also going to be 9, which means the whole thing, FH, is 9 plus 9, which is 18. Okay? So there we go. Have a good day. Thanks for watching.